I'm recording this one because this morning's version, I froze, so I had to come back in toward the end, and I just as soon have a better recording of it. So I'm going to cut this off, and we're going to get back to the dot cam. I just wanted to say hello. I know that you're there, and I just want you to know that I'm a real live human being. Now is a good time, Christine, and we'll go over that. So if you have a question after I go over it, please ask. Okay, so let me get the dot cam going. And yeah, that looks way better. I reset with Documate, or whatever the name of this company is. So it's a better picture this time also, which is always better. Okay, where are we? We're at 2.1. We are going to finish, we're going to do 2.1 today. We'll do the first problem on 2.2, no big deal. We will finish through 2.4 next week, and then we will spend Wednesday doing the review. Wednesday, Thursday, and Friday, you'll have to take your test. From Wednesday, I'm going to open it up about 10 o'clock so the morning people can take their test then, but don't go take your test until after we've done the review together. You want to see what I'm telling you about the review, because I built the review and I built the test. And so I know what you need to know. So wait at least until Wednesday after we review. You'll have all Wednesday night, all the time Thursday from midnight to midnight, and all Friday from midnight to midnight. Okay, I want to take a second and travel with you to, here's good. Let's see, let's go back a ways. Not gonna be able to do that. Hang on a second. Let's stop sharing there. Go back. Okay. I think that if that can persist, no, I don't want to do that. Crap. Hang on a second. I'm not sure why I'm not able to. Hang on a second. Let me see if I can figure out. Yeah, okay. I don't see a problem here. My math lab. Okay, there we go. Let's come back to here. I want to go down to lessons, start there. These are the worksheets that we're going to be working on today and Wednesday. You don't have to print them out. You can follow along with mine. You can do whatever works for you. Whatever works, you'll have to figure that out. We won't have a ton of worksheets, but there will be some. Graph paper, it'd be nice for you to be able to practice on graph paper rather than a sloppy graph, but again, you decide. If you don't have a lot of free money, then see how winging it works for you with a sloppy graph. Your Proctorial practice test is due Friday. It's up and posted if you go to Proctorial Test Proctor and then click on the bottom link here. Your exams are here. And then this one is your exam. The instructions are here. The two things that I've seen, well, there's one thing I've seen people do. They're showing me their ID card. You don't need to do that. If you want to, that's fine. But I already met with you. I know who you are. So you don't have to show me your ID card. The second thing that I want to tell you about is number 4. I need your scratch paper sitting on your work surface as you turn each page over so I can see both sides of every paper as they sit on your work surface, not flapping around in the air as you hold them up in front of your dot cam. You're going to have to pick in front of your video camera. You're going to have to wrestle with your computer, those of you who don't have exterior cameras, and get that to me as Ms. Campbell shows in her 3-minute video. And then get your scratch work to me within 5 minutes, not 7 minutes. It's a 5-minute thing. Go back here and see who just popped up with something. Oh, okay, that's fine, Hugh. That's fine. There are no tardies in this class. I'm glad you're here. I'm very glad you're here. So that happens. Let's go back to lessons. That happens this week. You got, today is Monday. You've got through Friday to get that going, get that practice test to me, and I will give you feedback on if it's wonderful and you're good to go, you understand everything, or if you need to do a little bit more playing with it. Okay, I think we're good here. Let me go back here and get back to the dot cam. And here we go. Okay, so let's get started on 2.1. First thing we're going to do is a thing on domain and range, and is it a function? Is the set of points that we have a function? Those are the three things we're looking at. So let's look at our first set of points. We have a brace there, and then these points. -3, 6, -2, 5, 0, 0, the origin, and 5, 5. Oh, and something I want to tell you about the practice test. You're going to get a 0 on it because you're not putting braces around there, and so it's marking it wrong. On a multiple choice test, that won't be a thing, and when it is a thing, if it counted for a grade, I would go in and correct all of your answers. So don't worry about that you're going to get a 0. That grade on the practice doesn't count at all. It doesn't factor into your grade in any way whatsoever. But if you, those of you who haven't taken it yet, if you want to get it right, like if you got 7, then build the braces around there. And the braces are the ones that on my keyboard sit beside the P. They're shift keys on the P. If you use those braces, then you will get credit for your answer. That's what TestGen requires, is braces around answers. My math lab, not a problem, as you've seen. Okay, so domain, that's the set of all the X numbers. So you know with each point, the first number is the X coordinate, the second number is the Y coordinate. So the domain is going to be -3, -2, 0, and 5. That's the domain. We're just grabbing the X coordinates. The range, we're going to grab the Y coordinates. So we've got 6, we've got 5, we've got 0, and we have another 5, that last one there. We've already written a 5, so let's not write it twice. So that's the range. This is the domain. They don't need to be in numerical order. My math lab, if you ask, like, view an example or help me solve this, they'll give them to you in numerical order, but yours do not need to be in numerical order. Now, is it a function? It is a function if X does not repeat. So I'm just going to go through and say the X's. -3, -2, 0, 5. I didn't repeat. So yes, because X doesn't repeat. It's a function if X does not repeat. Let's look at another one. Let's look at this set of points. Got 4, 7, 4, 8, 5, 6, and 5, 3. That set of points. Let's look at the domain. The domain, remember, is the X coordinate. So 4, got a 4 there. I won't rewrite it. 5. I've got another 5 there. I won't rewrite that. The range is the set of second points. So 7, 8, 6, and 3. And then is it a function? It's a function if X doesn't repeat. So say the X's to yourself. 4, 4, we ran into a problem. This is not named a function because the X repeats. You can't have that happening. Let me show you what happens visually. We've got another way of testing this. The way we've got of testing this is called a vertical line test, where we're just going to run a vertical line down our graph. So let's see. Let's say that we have got that line right there. We're wondering, is it, well, let's wonder domain and range first. Domain here, on the graph, domain is looking at the X coordinates. What of the X axis that this orange line uses up? Well, you can see that it uses up like -1 and 0, and this will drop down to 1 and 2 and 3 and 4, and it extends on forever. So it's going to take up all of the X axis going out to the right to positive infinity. But it's also going to do the same thing over here, where this, as it shades down, will be like -10. And then it's going to take up -15. And then it's going to move way down here, and it'll take up on the x-axis, it'll take up -20. And eventually to -infinity. We read from left to right when we do these numbers, so it'll always be small values to large values. So what this line takes up on the x-axis is every stinking thing. -infinity, everything. Let's look at the range. You know that the range is the y-coordinates. That's this axis. That's the thermometer. You can see that these temperatures go down here to -10. It'll extend down to -12 or -15. It'll keep going down and down and down. So we're going to use up all of the negative numbers. Same thing's happening here. This one, as it extends, that's like 4. It'll go up a little higher, and it'll hit the 5 on the y-axis. Goes up, it hits the 10. It'll keep going up. It'll eventually hit +infinity. So same deal here. We have to start with the negative numbers and progress to the positive numbers, always. So x-axis will always go left to right. Y-axis will always go bottom to top. Now, is it a function? The vertical line test means any vertical line you drop down here is allowed to hit the x-coordinate once. Is allowed to hit the line once. So if we drop a plumb line here, ding, it just dinged there. It hit the line once. Once is good. Let's drop another vertical line. Ding, it hit there. Once is good. There's nowhere we can drop a line that'll hit more than once. So this is a function because just like up here, x doesn't repeat. We don't hit an x-coordinate more than once. Let me show you what a failed one looks like, and you'll see the difference. Let's do another set of sloppy graph here. And let's look at, say, this guy right here, an egg sitting there. Let's look at domain and range, and then we'll look at, is it a function? So the domain is what of the x-axis the orange part takes up. So the orange part, let's say that this right here is at -5, and let's say this is at 5. So the orange part, this half, this semicircle, will take up -5 and -4.9 and -4.8 and -4 and -1, 1, 2, 3, 3.5, 3 3/4, 4, 4.9, and 5. So we don't take up any of this stuff out here on the number line. So our domain goes from -5 to +5, and we have braces here to indicate that it includes -5. We're actually hitting -5 there. We're actually hitting +5 there. The range, that's what of the number line we're taking up. So we start taking it up right here. Let's say that this is -3, and let's say we go up to here to 3. We don't take up anything above 3, and we don't use up, the orange does not use anything up below the -3. But it does use up everything in here. This is using up the 2, this is using up 1.5, this is using up 1/2. That dot right there uses up 0 on the thermometer. This one maybe uses up 1.5 on the thermometer. So we use up all of this span here. Remember, you have to start at the bottom. I know you want to say, I know some of your brains want to say 3 to -3. We can't do that. We have to start at the bottom. So we go from -3 to 3, and we'll use braces there because it starts and ends with at those points. We don't have an open circle there. Now, is it a function? No, it is not. Let's look at, say, if we drop a vertical line test down. Let's say we drop it, boom, hits there. That's cool, no problem. But it's going to hit there also. That x is going to repeat. So this is not a function. It flunked the vertical line test. Let's look at y. Let's look at that point. That point sits at about 4, 1. We go out 4 and up 1. This point seems to sit at about 4, -2, let's just say. You see where the 4, the x is repeating there. One of the points on this orange egg is 4, 1, and another one of the points is 4, -2. The x is repeating, and that's a no-no in a function question. So this is not a function, and we won't be playing with too many of those. this is a function, we'll be playing with some of those. That's what we're getting into. Let me pull this up. We are preparing here in 2.1 through 2.4 so that we can look at 2.5 through 2.7. We'll be playing with these four to learn some stuff to help us with this. So we're getting ready for test 2 right now. Almost everything we do in this class is not done because I like numbers or because somebody hates you. It's done to prepare you for the next thing we have to do. So know that that is happening every single time. What you learn in class today, you're learning because you need to know it for tomorrow, kind of thing. All right, what is next? Oh, and then this answering this question is y a function of x? That's the question we're answering when I say, is it a function? Is y a function of x? You'll see that wording. Okay, next thing we're doing, the question will be, does the equation define y as a function of x? Same kind of thing. We're just looking at functions in terms of equations now. We've looked at little bitty points. We've looked at 2 drawings, 2 graphs, and now we're going to look at straight up equations. I'm going to show you 4 of them. One of them is a no, the other 3 are yeses. 3 of them are functions, like this, where they'll pass the vertical line test where x's don't repeat. One of them will be a no-no. One of them will be where x repeats. Okay, let's look at how we can figure that out. X plus y equals 11 is our first one. And what we're looking at there, first thing you want to do is get these into y equals. Solve for y, and then we can look at them a little better. So I'm going to move the x over, and I've got y equals negative x plus 11. That's a line, just like this is a line. That's in y equals mx plus b shape, form. Look like this. We got positive 11, let's say that's up there, and then the slope tells me go down 1 and over 1, and there's that line. That's going to pass the vertical line test. So this is a yes. Does the equation define y as a function of x? Yes, it is a function. This one is a function. Lines are functions. The only line that's not a function would be a straight up and down function, and we won't get into that. We're not going to muddy the waters with the one exception. Let's look at our second one of 4 here. X squared plus y equals 9. Again, solve for y in order to determine if the equation defines y as a function of x, to determine if this is a function or not. So I'm going to move the x squared over to the other side, and I get y equals negative x squared plus 9. This is a parabola because it has an x squared. You don't need to know that at this point. Don't worry about that. But what I want to tell you is this is going to be a parabola, but it's going to go down because it's got a minus sign there. So instead of looking like that, like a bucket, it's going to look like an umbrella with a negative in front of it. And we are going to take that normally sits at the origin, and we're scooting it up 9. All that is just free. Don't save that information. We'll hit it again and again and again, and you'll be able to do these in your sleep. So what I'm telling you, though, is that this is looking like this, and it will pass the vertical line test. No problem. Okay, so this one, yes. The question is it a function? Does the equation define y as a function of x? Yes. Let's look at our one that says no. X minus 7 equals y squared. Again, we want to solve for y, and if we're going to get that y by itself, we need to take the square root of y. So we will end up with y, you know that. And if we take the square root of one side, we have to take the square root of both sides. Oh, look what we just did. We just put a radical on part of the equation. And when you do that, you have to consider both the positive and negative versions of the square root of x minus 7. So what happens here is that if we have an x, we're going to do something with it and end up with both positive and negative versions equal to y. Let me give you an example. Let's let x equal 8. Put an 8 in there. 8 minus 7 is 1. So this is now plus or minus square root of 1, and you know the square root of 1 is a 1. So we've got the point 8 positive 1, because plus or minus 1 equals y. And we also have the point 8 negative 1, because we've got a negative version of 1 equal to y. So there's our negative version of 1 and our positive version of 1, and they both happen when we plug in 8 for x. So there's the x repeating, and that's not a good thing. So this is our no-no. When you put the radical on, you know you're going to get two versions. That's going to lead you to two y answers. A plus y, or a plus whatever this is, will be your y, and a minus whatever this is will be your y. Two different versions with the same x. So that's the no-no. It's the only one you've got to watch out for. We're not going to dig too much deeper into this. The point, I think, with this is just to give you a little more algebra work. Let's look at our fourth one that is also a yes. Y equals the square root of x plus 25. If you are given this, it's already in y equals, it's already solved for y. You did not put the radical on, so you'll only get one answer. So let's just pretend like x is 9. Put it, how about 11? Can't do the math. X is 11. Put in an 11 there. 11 plus 25. That gives you 36. Square root of 36 is 6. And remember, in this country, we take only the principal square root unless we put the radical on. Then we take both. But we didn't put this radical on. So y is a 6. So the point is 11, 6. X was 11. Y was 6. And this is perfectly fine. This last one is perfectly fine. It's just when you put the radical on half the equation that you end up with two different y answers. That's the no. The others are yes. If that's all you know from it is to go through those four problems going yes, yes, no, yes, I'm good. That's all you need. We're not going to take that much further that you will recognize as applying to anything you're doing in your life. Okay, let's go back to a little bit more algebraic stuff. Let's say that we have got this equation. H of x equals x to the fourth plus 10x squared plus 4. We're going to play with two different equations here. This is the first one. This is h. They're going to give you answers they want you to plug in. So what this says is take the h equation and plug in a 0. So let's do that. Let's take this h equation, and every time we come across an x, instead of an x, you're going to substitute a 0. So we get 0 to the fourth, 0 squared plus 4. 0 to the fourth, you know, that's gone. 0 squared, remember we have to do exponents first, the order of problems. Parentheses come first, then exponents, then multiplication and division. So we've got to do 0 squared, that's a 0. 10 times 0 is a 0, and we end up with a 4. So if you're asked to make a point out of this, and you won't be at this point, you will be later. You know what a point is. Let's see, let's find the x. They told us to use 0 for our x, and when we did, we got a 4. H of 0, h of x, that's the new way of writing y equals. These both say y equals. This just gives it a special name, h, and it tells you you're going to see some x's over there. But it still just says y. That's the same thing. So this h of 0 equals 4 is also saying y equals 4. So that would be the point. They give you the x, they give you the 0, you figure it out by plugging in to find the y. The question would be asking us to insert 0. Yes, and that's just an example. They'll tell you what to plug in. They'll tell you find h of 0. Next thing they'll do is they'll say find h of negative 1. So they will tell you what to plug in for x. These are ones that I have stolen from my math lab. They're telling you what to plug in. So let's go over to our original equation, and everywhere instead of seeing an x, we're going to plug in a negative 1. So negative 1 to the fourth power plus 10 times negative 1 squared plus 4. Okay, you got to be careful. You've got to be not sloppy on your calculator. This is saying both the negative and the 1, because they were x, both parts are getting raised to the 4th power. If you get sloppy and you just put into your calculator negative 1 to the 4th power, it's not going to do anything with the negative. It's just going to move that negative over, and it's going to say 1 to the 4th is 4. I kind of messed this up. That looked like an equal sign. So there. But if you want it to know that negative 1 is the x for you, not just the 1, you got to put it in parentheses. Then it'll give you the correct answer. So watch out for that. If you have 2 parts to a number, a negative and a number, put them in parentheses if you want everybody raised to that power. So negative to the 4th power is a positive. 1 to the 4th power is a 1. Here, let's do exponents first. Negative 1 squared gives you a 1. 10 times 1 is 10 plus 4. So we're getting 15 out of that. So again, if you were to make a point out of this, they've told you that x is a negative 1. They've told you to plug it in. When you plugged it in, you got 15 for your y coordinate. Let's do another one. Here comes a seriously important one.
I got a question.
Yes, sir.
Oh, what happened to negative 1 and what happened to that negative 1 in quotations with 2?
That negative 1, that's negative 1 times negative 1, that gives you a 1. Positive 1, so 10 times 1 gives you 10.
Oh, okay.
You sure?
I'm not sure.
I don't think so. Yeah, saying okay is kind of lying, isn't it?
Yeah.
So this is negative. This says take negative 1, take what x is, and square it. So that means write it twice and multiply it.
Yeah.
Negative times a negative will give you a positive. 1 times 1 is a 1. So that's where that 1 comes from.
Okay, that makes more sense. Okay.
Okay, keep
Yeah.
asking. Answer.
Yeah.
Okay, now what we're doing will not belong in your calculator. It's negative x, but it is hugely important in 2.2, and we will pick up that skill and we'll use it again. Instead of x, everywhere we go, we're going to put in a negative x and see what happens. So instead of this x, let's put in a negative x and raise it to the 4th power. Then a plus sign, then a 10, then x. Oh, but remember, every time we find an x, we're going to put in a negative x. Square it, then a plus sign, then a 4. Okay, this negative x to the 4th power, that means negative x times negative x times negative x times negative x. These two negatives cancel each other. Those two negatives cancel each other, so we get a plus, and then x to the 4th. So this piece will just be x to the 4th. This piece right here says write negative x twice and multiply. Negative times a negative gives you a plus. X times x is x squared. I'll show you in just a second, Abdul. So we get x squared here. That piece is x squared times 10 is 10x squared plus 4. Okay, the huge piece of what we've done here is that we started with this, x to the 4th plus 10x squared plus 4. And when we plugged in a negative x instead of x, we got the same dang thing. That's going to be significant to us. When we plug in a negative x, what happens to this? Does it stay the same? Does it do the opposite? So that's going to be important to us. This is just giving you practice today on that. Okay, so the question was, how do you do the square? And I totally appreciate that. And I know that it got answered, but I still want to show you because then it'll be up on the, I don't think the comments, no, the comments do transfer. But anyways, who cares? 3 to the 2nd power, 3 humpy 2. That caret key over there on the left-hand side, that says 3 to the 2nd power. You get a 9. That'll work for negative 1, but you got to put it in parentheses in order for that to happen. You've got to use the parentheses there and use this negative sign. So it'll be open parentheses, negative 1, close parentheses, then raise it to the 2nd power, caret 2, and you get a positive 1 out of that. Okay. And then finally, they want us to do h of 3a. So they want you to take this original equation, and everywhere you find an x, instead of putting an x, put a 3a. So let's see, that says x, so let's put a 3a, and because it has two parts, a 3 and an a, we are going to need to parenthesize that to let us know that we want to raise everybody in there, both the 3 and the a, to the fourth power.
Question.
Then a plus sign.
Back when you were doing the h negative x, and we found that equation, is there just not a point?
Oh, there's a huge point, Kaylina. It's that you got exactly the same thing we started with. Doesn't mean anything.
Okay.
It means something to you on Wednesday. We'll explore that on Wednesday.
Okay. Thank you.
You get a number. You don't get something satisfying like 15 or 4 because you didn't put in a number. You put in a negative variable. But the fact that you got the same thing, and they don't expect you to be going, holy crap, I got the same thing. They're not expecting that right now. We'll do that on Wednesday. This is just giving you practice, just getting your toes wet so that when it happens to you on Wednesday, you have a little practice at seeing what happens there. They're just laying the seeds for you. It's a good thing. Okay, so let's put in 3a to the fourth power plus 10, and then 2.2, Gabriel, just 2.2. Gabe, sorry. 10 times x, that's a 3a to the second power plus 4. Okay, so all I did was substitute in 3a all over the place for the x's. 3 to the fourth power will give me 81. A to the fourth power is just a to the fourth power. Plus, now remember here, you're not going to get a 30. PEMDAS says you first have to do exponents. So 3 squared gives me a 9. Let me just write that in here. 3 squared is a 9. A squared is just a squared. So we end up with 81, a to the fourth. Now we get to multiply those two, 90 a squared plus 4. And that's the answer. We plugged in a variable, so we still have variables in our answer. We plugged in a variable, we still have variables in our answer. Plugged in a number, we get a number. Plugged in a 0, we get a number. So if you plug in numbers, your answer will be a number. If you plug in variables, your answers will be in variable form. Okay, let's do another one. Let me give you f of x this time instead of h of x, no big deal, equals 3x squared minus 1 over x squared. That's just an erasure there. That's a squiggly. If I use a pencil, you can't see this as well, so I'm forced to use a permanent marker. But that is just a blob. So it's x squared in the denominator. Okay, again, they will give you numbers to plug in. F of 6 is the first one we're going to plug in. So when we see an x, we're going to plug in a 6. So 3 times, oh, there's an x. So I'm going to put 6 squared minus 1. And on bottom, I've got 6 squared. So remember, order of operations, you're not doing 18 here. I know that your brain sees it and wants to do it because it comes first, but that's not allowed. You have to do exponents first. So 6 squared is what we're taking care of. That's 36. Now we can do the multiplication.
Is that an F next to the X in the parentheses? Is that an F?
Yeah, this is just f of x.
Okay.
So we've got 3 times 36, which gives us 108 minus 1, and 6 squared is 36. So we get 107 over 36. You've got to reduce that if you can, and I know fractions are not, almost none of you, is that your best thing, fractions. So let me show you how you can see if this is already reduced. Let's do 107. And then you want to use this fraction bar. Don't do divide because it'll give you a decimal answer, and that's not going to be super helpful. We want to see if it can be reduced as a fraction. So use the ABC key right here. Anytime you see a fraction bar, hit the ABC key where it belongs. So ABC, and that looks kind of like a comma there. Let me put the 36 down there. So here, 107 over 36, that's the way your calculator will see it. 107 over 36. Hit equals, hit enter, and you get this that is read 2 and 35/36, because 107 is top heavy to 36. So we get a mixed number. Now, we don't want mixed numbers. Almost never will we use mixed numbers, and you might not be able to tell that this wasn't reducible. That denominator right there, 36, the fact that it's still a 36 tells me this did not reduce. But you might want to have your calculator tell you something a little that you can count on more. So let's take this mixed number, 2 and 35/36, and let's pile it up, make them reduce it in improper fraction form, top-heavy form. So let's go back to this ABC key. You can see above it, it has the mixed number A and B over C with a double arrow to DE. That's a mixed number to an improper is what they're telling you there. So let's get to that. Let's push second ABC equals, and we get back to 107/36. That's telling us that this is a good answer, that it cannot be reduced. Let me give you a number that's smaller in scale so you can get the feel for it. Let's say if you had 6/4. Yes?
When I did that, it said syntax error.
You did something goofy then. Let's start again. Clear your calculator, put in 107, and then hit ABC, and then hit 36, and enter. And you're getting 2 and 35/36?
Yes.
Okay. Now you want to pile it back up. So you want to hit the second key, and ABC, and equals.
Okay. I don't know what I did wrong in the syntax error, but I got it this time.
Good. Who knows what you did wrong? And that's what learning's all about. You learn more. Well, you don't learn much from that mistake because you don't know what you did. But you learn more from mistakes. So you're good. Let me show you why this works. 6/4. I mean, everybody in here with a little bit of time could tell me that this reduces to 3/2. But let's let your calculator show you. 6 ABC 4, that's 6/4 right there, equals, and they give me this mixed number. That's what they're always going to go to, is the mixed number. That's 1 and a half, 1 and 1/2. I don't want it mixed number. I want it improper fraction. So I'm going to hit second ABC equals. And there I get 3/2, and I can tell that it got reduced because the denominator changed. So I know that they reduced it for me, which they always will. This one will always, oh, it's so sweet, Austin. It'll save you every fraction that you used to have to do by hand. That little key right there is your friend. If you decide, you know what, I like that number, but I'd rather see it as a mixed number, do it again. Second ABC equals, there you are, you're at 1 1/2. No, I really like the piled up one. Second ABC equals. It'll toggle back and forth for you. Yes, Abdul.
My calculator is a little bit different than yours.
Then you're going to need to get one that's not different.
I mean, it's
you've got to have this calculator.
It's the same model. It just says multi-view because I used this because I took college algebra before, and my professor said it was fine. Instead of saying ABC, mine just says N/D.
Yeah, I'm going to need to see a picture of that. What did you say it was? Read to me what it says up here.
It says TI 30XS multi-view.
XS multi-view.
Yeah, I can email you a picture of it.
I can Google that, or as my best friend says, I'll do a Google on that, so her children get embarrassed at her saying that, phrasing it that way. I will do a Google on that, and I'll make sure it's okay. I don't want you to spend extra money, but you got to have you can't have a fancier one than this. Is what we're doing. Okay. So can you figure it out with your calculator? Can you? I mean, I can bounce back and forth.
Yeah, it just skips the step. So I do the 107/36. It showed me that as a simplified problem instead of me clicking the second and that. So it gives me the answer. It's just a little different.
Great. As long as you've got it, and then I will get back to you on that.
Okay, thank you.
Abdul. Okay. Abdul. Okay. Let's do f of -6. Let's do the same problem, except this time, instead of putting in a 6, let's put in a -6 and see how it goes. So 3, then we've got x squared. Let's put in a -6 squared, -1, over -6 squared. Be sure that you're putting the negative also in the parentheses because your job is to square both the negative and the 6. Your job is to square everything that sits there. Okay, so let's do exponents. -6 times -6, that gives us a positive 36. -6, written twice, -6 times -6 gives us a positive 36. So we end up with the same old thing, 107 over 36. Okay, and just for fun, they're going to ask you to plug in a -x. Do the same thing, take this original equation and see what happens if instead of an x, you plug in a -x. So let's see, we got 3 times -x squared minus 1 over -x squared. See what you can do about simplifying that a little bit. So do this first. You're not going to be doing -3x. Take care of exponents. -x times -x will give you a positive x squared. So we'll get 3x squared minus 1 over x squared. There's our answer. We plugged in variables. We're only going to get variables. And notice that it matched. When we plugged in a -x in place of x, we plugged in a different variable. We ended up with the same thing. There's a reason for that, and we'll explore it on Wednesday when we do 2.2. Okay, now we are looking at the first worksheet for 2.1. Hang on a second. Let me separate this out. And here we go. Okay. F of x equals...
I got a question.
Yeah. Sure, Anthony.
So we don't need that, right? We don't need the worksheet, but we can work it out on paper, right?
Yeah, you can follow what I'm doing, take notes as you need to, write sloppy graphs, take care of it. Just figure out how to get it into your notes so that it makes sense to you. If you want to take a picture to go along with it, I don't know if that's helpful to you or not, but you figure out how it gets it done for you.
Okay.
Dave, you have a question?
No, actually, sorry, I didn't mean to turn on my mic.
Oh, it's okay. It's okay. Kaylina.
How are we gonna turn in this paper then? Are we gonna?
You're not.
Like, oh, okay.
You're not. We're doing this together. That's what homework. That's what classwork is all about. You'll have,
Okay.
and I need to draw these in advance because it's easier for me then to work with the notes so I get them right. That's all. This is just more helpful for me. If we were in a classroom, then you'd have these and you'd pick them up at the back of the room as you come in each day, or you'd miss them, and I'd say, Kaylina, grab the papers at the back on your way into your desk, and you'd, oh, okay, and you'd go back and you'd pick up your papers and come and sit down, but we don't get to do that this semester. So this is just, you're not turning this in, just as in the same way that you're not turning any of this in. This is just your notes. Okay, so we have got f of x equals x. That's the same thing as what you used to have, y equals x. That's the same exact thing. This f of x equals x, though, is a parent graph. This is one of our graphs that we are going to be using over and over and over. F of x equals x. Let's look at it in a T-chart. X, what we're going to put in for here, but we're going to stick in over here. Let's just try -1, 0, and 1. I'm just showing you what this will look like. If we get f of -1, that says go over the other side, and everywhere you find an x, put that number. So we go over the other side, x is sitting there, let's put that number. F of 0, same thing's going to happen. It says equals x. So we get 0, 0. F of 1, same thing, says equals x. So we get a 1. Let's graph those points. -1, -1. Remember, you start at 0, 0. If we're graphing -1, -1, first we go to the left on the x-axis, then we go down on the y-axis. There's that point. Then 0, 0. Then 1, 1. Over 1, up 1. And this, my friends, is the first parent graph that we have. This is f of x equals x. It draws a 45-degree angle through the graph. It goes at a 45-degree angle. Now what this one, g of x, does is it takes that exact same thing, x, but it shifts it down 3. It takes each one of these x values and subtracts 3 from it. Let's look at it on a t-table. Let's take those same 3 values that we took over here for f of x, and let's plug them into g of x. So we have -1 minus 3, that's -4. We have 0 minus 3, and we have 1 minus 3. So we end up with those points. Let me grab a different color marker. -1, -4. -1 says go -1 on the x-axis. -4 says go -4 on the y-axis. 0, -3. 0 says don't go sideways on the x, stay here. -3 says go down 3 on the y-axis. 1, -2, +1, -2. And there we have g of x equals x minus 3. So what happened here, what will happen here is that you will, they're going to force you to do this. They're going to force you to do t-tables. Just play their game, fill it in. That's math, that's algebra, you're learning something. But f of x equals x will always be this line that goes diagonally through. Then they're going to take you on this one where you're going to say, okay, I know g of x equals x is this, and that tells me to go down 3. So from here, 1, 2, 3, boom. Here, 1, 2, 3, boom. Here, 1, 2, 3, boom. So they're going to ask you about the shift. Got to be careful saying that word. The shift. And what happened from f of x to g of x is that we shifted down 3 units. That's what they're looking for. They're looking for down in a drop down, and then I think you have to put in the number 3. But that's what's happening. You can tell it's happening right there. Test 2, we are going to be doing that out the wazoo. We are going to find a parent graph, and then we are going to shift it in some way. Sometimes we go right or left, sometimes we go up or down. We'll just see. We'll learn in test 2 how to do that. But for now, all they want you to do, they'll give you some numbers to fill out. They'll give you the x's, no problems there. You just plug them in, and then they'll ask you about the shifting. I think you have to graph both of them there. So it's not too difficult. It's just leading you to the next step. Which part, Christina? Well, I guess if you knew, then you would know. But where are you uncomfortable? Christine? The shift, okay. The minus sign tells you it goes down, so that's why you'll use the word down. And then the number 3 tells you it's shifting 3 units down. So if it'd been x plus 5, it'd be shifting up 5. So the shift is just what are you doing to the black line to make him be the orange line? Is that better, Christine? Good.
In the case of this problem, how would you know whether the shift is going down or left?
That's a whole nother story. Chapter 2. I'm just going to make you wait for that.
Okay.
It's easy, though. It's very easy. That's a great question because it is a minus, but the one that you will have will be an up or down shift. We will do that the first day after test 1 test on section 2.4. I'll answer that question for you. Okay, let's move to the next one. In this one, this little mess of a graph is f of x, and they are going to ask you to find where, they're going to ask you to find f of 4. Okay, so that is an x. They're giving you the x. They're asking you to find the y that coordinates with that x. So let's go out to where x is 4. 1, 2, 3, 4. So we're right here. We're looking at this line right here and trying to decide where our graph is. Well, you can see our graph is right here. So we're actually trying to figure out the name of that point. That's where the x value is 4. 1, 2, 3, 4. Let's figure out what the y value is. 1, 2, 3. So that point is 4, 3, where the x is a 4 and the y is a 3. You can go over here and count it, 1, 2, 3, or you can just figure out what the name of that point is. His x value is 4. That will be given to you. You have got to determine his y value. We're going to do that a bunch today. Okay, let's do the opposite of that before we do this a bunch. Let's do the opposite of that. They're going to ask you for what value or values, is g of x equal to 3? So they're asking you to come up with the x, and they're giving you the y. So let's figure out where that is. Let's go find where the y is 3. On the y-axis, 1, 2, 3, right there, that's where y's are 3. Everything up in that neighborhood, the y's are 3. Now let's look at where our graph hits where y is 3. It hits it right here, and it hits it right there. One on the way up, one on the way down. So there are 2 values for x, where g of x equals 3, and they want those numbers off the x-axis. So let's see, we've got a 0, and there's a 1, so that's a 0.5. That's one of the places, x equals 0.5. The other x, 1, 2, 2.5. So those are the 2 answers, 0.5 and 2.5. And that's what you'll answer. So this is the opposite of this one. Here they give you the x, you give them the y. Here they give you the y. So you're looking for where, remember this g of x is the same thing as y equals. You're looking for where y is 3, 1, 2, 3. So you're up here in the heavens and see, and there's the place it crosses. So that place right there is 1/2, a 0.5, and it crosses again on this y equals 3 line. So this point right here is 0.53, and this point right here is 2.53. They're giving you the y, asking you to find the x. All right, let's grab the second sheet here. We got a lot of little things to find on each of these. First thing we're finding is domain. These have arrows. Those are indicating that they are going out forever. So the domain of this will be, what does it use up on the x-axis? Well, I can see that this line is going to take it all the way down to, -7, down here to -10, off of your screen to -infinity. This is going to carry it all the way to -infinity. Slowly, but it'll get there. Same thing is happening here, and it's a continuous to 0, 1, 2, 3, 4. This will continue going out and in the positive direction. So we're taking up the entire x-axis with this parabola. This is the shape of a parabola facing down. Let's look at range. Range isn't as simple. Range is, what are we using up on the y-axis? What are we using up on the thermometer? Remember, we start at the bottom, and sure enough, these pigtails, these little ponytails are going all the way down to the bottom. So we are definitely starting at -infinity. We're going to be using up on this thermometer -infinity. Then we come up here, and sure enough, they're going to be down here at -10, then -5. You can see you can scoot these over, -4, -3, -1.5, -1, -0.1, 0, 1, 2. Where does this stop using up the y-axis? It stops using up the thermometer right there. So let's call that 1, 2, 3, 4.5. So it goes to 4.5. Let me talk about that decimal amount. When you go to do your My Math Lab, stuff will normally end on whole numbers, 3, 4, 5. If it doesn't end on a whole number, if this is somewhere in between 4 and 5, you can count on it being the half. They're not going to say, no, it wasn't 4.5, it was 4.3. They're not doing that to you. So if it's somewhere in that nether region between 2 whole numbers, count it as a 0.5 when you're eyeballing these. Okay, and we did get to 4.5, so we're going to use a brace there. A bracket. That's called a bracket. We're going to use a bracket. Okay, next thing they want from us is X-intercepts. Those are our zeros. That's where it crosses the x-axis. So we're looking at that point and that point. Those are our X-intercepts. Let's see, this one is -1, -2, -2.5. So -2.5. I think they tell you they want fractions. And then we've got 1.5. Okay, next let's look at the y-intercept. Where does it cross the y-axis? It crosses the y-axis. Let me put a blue dot on that. Where, not up here at 4.5, but it crosses the y-axis right there at 4. So the y-intercept is a 4. It's where it actually makes contact with the thermometer. That happens a little bit short of its highest point. Drops it down to here. And just so you're thinking about it, this is a maximum. This is a roller coaster ride. You always start on the left-hand side and go to the right on these roller coaster rides. So you're going to be climbing here, increasing, increasing. That's the maximum, and then you'll be decreasing. That's pretty logical, I think. That's not something you're going to have to learn special for math class, but we will look at it in a minute. Yeah, Humberto, that's just what happens with the range. Let me try again, but know that that might be an area that not only you, but others will struggle with. The range is, you're used to this. You have to shift your brain to this and think about what are you using up on a thermometer. Start with the freezing temperatures. Yeah, these go all the way down there. They use up negative infinity. So they start at negative infinity. Now figure out if you can see where is the last place on the thermometer on the y-axis that our graph uses up. So here it uses up 4, but it goes higher than that. Right there, it's going to use up the y-axis at 4.5. So you're looking for the highest point that your graph goes. What is that equivalent on the y-axis? And that's why we did 4.5. It takes practice, and trust me, my friend, you will get practice. Okay, does that help somewhat, Umberto? And you can say it doesn't. Okay. Yeah, printing the sheets is helpful, but I know you guys are not, not every one of you has tons of time, tons of printer ink, tons of paper, tons of time to go to Staples or whatever. I will give these to you on Sunday, or even earlier than that. I end up usually making my new slide on Thursday or Friday. So you can, if you would like to, pull them off on Thursday or Friday, and you'll have until Monday or Wednesday to print them up, depending on which one. Yeah, I know. It is just better to have it. And absolutely, if we were in a classroom setting, you would have it. There are printers on campus, and they do cost a little bit of money, but there are printers on campus where you can go and print this, or you can just go to Staples and, put it on a stick and stick it in there. Yeah, we're doing 2.2, and that's got more pages of this. Yeah, this has got some printout sheets for sure. Yeah, it just might be worth it to you guys to take the time. Okay, let's keep moving. F of -3. We've done this before, but it's still, for some of you, kind of new. This says, there's the X. You go figure out what the Y is that corresponds with it. So let's go out to where X is -3. This is the Y, this is the X axis. Let's go out to -3 on it. -1, -2, -3, right there. Now, you're not going to travel up to find what goes with it, what the Y is, because there's no drawing up here on this -3 line. You need to go down this way to where -3 line hits our graph, and it hits right there. And that Y value is -1, -2.5. So we get, when the X is a -3, go to the point, travel to the point, and name it. It's -3, -1, -2.5. So the X coordinate of the point, of this point, the X coordinate is -3. The Y coordinate is -2.5. Let's find F of 1. Go and find 1 on the X axis. Here's the X axis. 1 is right there. And now go after the graph. We're going to have to climb up to find our graph. And I'm just going to say it's right there. So the X coordinate is a 1. The Y coordinate is a 2. That's what we're doing there. Okay, let's go to this one. Domain, range, And let's see, one last thing I want to do is we've named the X-intercepts as -2.5 and 1.5. If you did developmental math, our book that we use would have you having calling it, this X-intercept would be -2.50. This one would be 1.50. They would make you label them as full points on the x-axis and the y-axis. They would make you label this Y-intercept as 0, 4. That's what the old book would do. The book for college algebra just asks you for the specific point, just on the x-axis, just on the y-axis. So it'll just be one number. So if you're used to doing that, if that was niggling at your brain, that's what you were doing. Okay, domain here. This is different. This has a starting place and a stopping place, no pigtails. We're going to have a definite starting place and a definite stopping place on both the domain and range. No infinities. No infinities at all on this second one. Okay. Domain is what does this use up on the x-axis? Remember, you have to start on the negative side. There's no drawing over here. No drawing, no drawing, no drawing, no drawing, no drawing till I get right there. On the x-axis, it starts at 0. And it's a closed circle. It's a filled-in circle. So I'm going to use a bracket to indicate that 0, yes, indeed, 0 is part of my function. And now I'm scooting across here. Okay, 1 is included. Bring this graph up, 2, 3, 4. That's where we come to an end. That's the last place that the x-axis gets used up on this function. It stops there at 4. There's nothing out here. This guy doesn't extend here. So it ends at 4, and be careful, that's an open circle indicating to you that 4 does not count. 3.9999 infinitely does count, but 4 does not count. So use a parenthesis on the 4. Open circles, you can't include that number. Now let's look at the range, which I know for all of us is a little bit more challenging. The range is the y-axis, and it is like a like a thermometer. It's like a thermometer. Yes, you can sit and watch right now, and it is posted, but it takes a minute for BBCU to process it. So it might be 15 minutes after we're done before it'll be posted there. It's just a matter of time, though. It'll say in process, in process, in process. So yeah, you can just kind of hang out and listen to the rest of this and then catch up later. So you would enter, yes, that's exactly what you would enter in my math lab, yes. Brace 0, 4, parentheses. Okay, let's look at range. Range is the y-axis. Remember, you have to start down here. There's no gray down here. This does not go there. It stops right there. So -10, no. -8, -7, no. -6, no. Ooh, -5, right there. Scoot this over, and you can see that we start using up at -5. So I'm going to put a -5 there, but be careful. It's an open circle, which means -5 does not count. Right to its door, -4.99999 does count, but -5 does not, and that's indicated by the open circle. Okay, so -4.5, yeah, that's being used up. -4, -3, -2, -1, 0. Oh, but that's where we stop. We're not using up anything above 0 degrees. We stop using it up at 0, and that's included, so we put a brace there, a bracket there, sorry, that thing. We put a staple there, looks like a staple. We stop at 0. We don't go any higher. It's filled in, so we put a brace there. Shoot. We put that thing there. We put a bracket there. Okay, let's look at the x-intercepts. That's where does this thing cross the x-axis? Here's the x-axis. Oh, crossed right there. X-intercept is a 0. We don't have any other ways of crossing the x-axis. Let's look at the y-intercept. Where does it cross the y-axis? It crosses the y-axis right there at 0. Where can we find these papers? On my slide at Lessons at Blackboard. Because it tells you everything always that we're going to do for the week. And if you click on the link that says 2.1 and 2.2, up will pop these graphs for you, and you can print them out then. Y-intercept is where do we cross the y-axis here? Where does our gray function cross? Right there at 0. So the y-intercept is also 0. And then we're looking for f of 2. So take a second, see if you can figure out what f of 2 is here. Okay, let's look at this. Anybody got a guess? How many domain and range graph questions will be on the test? All of them. All of them are going to be domain and range. Oh no, we're not going to do domains. They'll all be range. 25 range questions. I don't know. A couple. A couple, maybe one, and we'll see, because the review, if you want to go out and look at the review, that will tell you how many you'll have on the real test. So the review is there for you to look at, and you'll get a sense. Good, Thomas. 3.5. Great, Jackie. So let's look. This is the X, 1, 2. Go down to the graph. That's the point we're trying to capture. That point is 2 on the X. We were already told that. And then -1, -2, -3.5. So we got that going for us. All right. Let's get out of that. We're done with the done with 2.1. Let's move to 2. No, we're not. No, we're not. And we're behind too, I think. Okay, let's see what we got going on here. Got f of x equals x squared minus x plus 5. And we've got g of x equals 4x plus 2. And we are going to find g of 7. And we also need to find that f parenthesis g parenthesis 7 and then a double parenthesis. So this is g of 7 and f composed of g of 7. Okay, let's find g of 7 first. It says go after the g graph, that's this 4x plus 2, and plug in a 7. So g of 7 will be 4 times 7 plus 2, 28 plus 2, that's a 30. So g of 7 equals 30. We're good there, no problems. Now we need to find this. This says go use the f function, but first go do the g of 7. Well, we just did the g of 7 right there. We did g of 7 and we got a 30. So this is asking us to do f of 30, because we know already that when we plug in a 7 into the g function, we get 30. So now let's go plug into the f function a 30. So we'll get 30 squared minus 30 plus 5. So 900 minus 30 plus 5, we get 875. So f composed of g of 7, go grab the g of 7, so it's f of 30, gives us 875, and g of 7 gives us 30. Okay, a company makes bikes, and we are going to figure up what their total cost is. We want to know what is their total cost, C, for making, when they make X bikes. Okay, let me tell you what you need to know. You need to know that the fixed cost for this company is $100,000. That's the money to keep the building open, to pay the employees, to pay their Social Security, to advertise for these bikes, to pay the security. 865? It's plus 5. Oh, be careful. If you're doing this on your calculator, it's not minus 35. It's minus 30, and then you add 5. So you can't combine those. That's a negative 30 and a positive 5. That'll give you a negative 25. If I owed you $30 and I gave you $5, I only owe you 25 now. So 900 minus 25. This orange is not true. You are not adding those up and then subtracting the total. So be careful of that. That is one of the ways that make math a little bit infuriating. I get that. How did I get 30? Because it says minus X. How did I get this 30, Umberto?
The second 30. On F30
Right
at the
there?
very top. No, at the top. Below
Up
the
there?
G7. That one.
Because G of 7 is 30. We just found it out.
Oh, so after you saw the first one, you put the answer
They'll
on the
give
second
you,
one, right?
yes.
Okay.
Okay. So this cost $100,000 to run our bicycle shop, to hire security, to paint the walls, to keep the lights on, all of that.
Does that say
So
bike?
what they're
Does that say bike total car? C?
total cost?
Oh, okay.
Total cost C of making X bikes. So let's see, we are going to find and interpret C of 100. First, we've got to find the total cost though. So the C of X, the total cost of this company, is the fixed cost, $100,000. That's whether you make one bike or a bunch of bikes. It's going to cost you $100,000 to employ all your employees and all that, keep the lights on. Oh, another detail that I neglected to tell you here is that it costs $120 to produce one bike. The metal, the rubber, the labor, that kind of thing. So the total cost here will be $100,000, the fixed cost, $100,000, plus the amount that it costs to produce bikes, and that will be 120X. If we produce one bike, it's going to cost us $120. If we produce 10 bikes, it's going to cost us $1,200, plus this fixed cost that we can't get away from. Okay, so let's find and interpret C of 100. We have found the total cost. This is the total. Now let's find C of 100. Let's use our formula. Let's take this formula and instead of X, let's plug in 100 every time we find an X. So it's $100,000 plus $120 times the 100 bikes. So we get 100,000 plus 12 times 1 is 12 with 3 zeros. So we get 12,000. So we get $112,000. So finding this number, there's the answer, 112,000, and interpreting it. If you make 100 bikes, if you produce 100 bikes, it will cost $112,000. That is, X is 100, Y is 112,000, if you wanted to make a point of it there. All right, let us grab the second graph. This is on my slide for this week. This is the 2.2. You can see it's 2.2 right there. And I've got it there for you. You just have to click on it. We're only going to do this first one today. Use the graph to determine A, open intervals on which the function is increasing, B, open intervals on which the function is decreasing, if any. That should be if any right there, although I don't think it's going to be too much of a problem for you. C, open intervals on which the function is constant. Okay, so let's do it. We're looking for where it's increasing. This is a roller coaster ride, and you're on the roller coaster. You always start on the left and go to the right. So you're here, you're not increasing, you're going down. Here's where you start increasing. This is the lowest point you're at. This is your minimum, and you are going up from there. So that's where the interval is increasing. It starts increasing at the bottom. Let's just say it's right there. Right there at the bottom, it starts increasing at 1, and it will continue increasing. These will go forever, so it will continue increasing to infinity. Infinities always have parentheses. Anytime you're talking about intervals, you're going to have parentheses. The reason being is 1 does not count. When you're at 1, you're not increasing. You're just sitting there. That's the bottom. You don't start increasing until you leave 1. So these will always be parentheses in intervals. Okay, let's look at decreasing. Where are you decreasing? Well, you can tell you're going to be decreasing here. Start on the left-hand side. So take this all the way up here, goes all the way out there to negative infinity. This piece, you know, this is what, -7. Then it'll go a little higher, it'll hit -8, -9, -10, and it'll continue on out there to negative infinity. So you start at negative infinity, you come screaming in here, you stop decreasing at 1. But you don't sit there at 1. At 1, you are no longer decreasing. So we don't really decrease at 1 for the same reason we're not increasing at 1. We're just staying there. C is looking for any places where we have got, where we're constant. And we don't have any constant places. There is no place like this on the second one where we're just hanging out on the same level, where our stomach gets a chance to breathe. Okay, let's look at some other things here. Other things we're going to be asked to find are relative, maximum, and minima. A maximum place or a minimum place. This does not have a relative maximum. Now, I know that you're telling me you go up high there and you start from way high there, but relative to the area around it. So you're finding where it changes direction. So this is a minimum. This is the lowest you get, so we do not have a maximum here. We have a minimum. And that minimum, go up to the x-axis, is a 1. It's where it is on the x-axis that counts. So the minimum is at 1. Let us look at domain. Domain here, remember that's what the x-axis is being used for. That's going to go all the way to negative infinity. And then this side goes all the way out to positive infinity. The range, a little bit trickier to find, I get that, but you will get good at that, Umberto and other folks. You will get better at it. The range, start down here at negative degrees. Remember, this is a thermometer that we're talking about. Where do you first pick up the graph? You first pick it up right there at -1, -2, -3, -4, -5. That's the lowest on the thermometer that this graph goes. So it picks it up at -5, and it counts at -5. This is not an interval, so it's actually sitting there at -5. And how high on the thermometer do you go? Well, in both cases, you go all the way up to infinity. So that's what we use up of the y-axis of the thermometer. There's nothing below -5, and it goes from -5 steadily with no breaks all the way up there. Let's look for zeros. 0 or zeros. Those are X-intercepts. That's all we're asking for. So the zeros of f, if this is an f function, you're asked to name where do we hit the x-axis. We hit it right there, and we hit it right there. Those are the zeros. Those are the X-intercepts. It's all the same. -1, -2, maybe -2.5. And then out here, 1, 2, 3, 4, 5, and a little bit. So let's say 5.5. Remember on my math lab, if it's not exactly at a whole number, count it as a half. They are. Okay, there is one more that they're doing for you later. So never mind that. Never mind that. We are done with this first one, and that's where we're going to stop today. We are caught up with the other class. And that's all I want to get to for us. So let's look at what you are doing. Here we go. Today, we have done 2.1. So in order to be caught up on Wednesday, you need to have done 2.1, be complete on 2.1. Don't worry about 2.2. We've got so much more to do on 2.2, but 2.1 is complete. So 1, 2, 3, 4 sections so far. This is our third week, and you've got 4 sections of homework to complete to be caught up. Also, your practice test is due this week by Friday, so get around to doing that practice test. It will take about 6 minutes. Once you've got Proctorial installed, the thing will take 6 minutes. And I think that's it. Any questions? I'm going to stop the recording.